Figure above is the graph of a function of x which models the height of a skateboard ramp. The function meets the following requirements. At x equals 0, the value of the function is 0, and the slope of the graph of the function is 0. At x equals 4, the value of the function is 1, and the slope of the graph of the function is 1. Between x equals 0 and x equals 4, the function is increasing. It's important that you understand exactly what these mean. So I've first translated the second and third one. The second one says when x equals 4, the value of the function is 1. That means plug x in to the original function and the output will be 1. The slope of the graph of the function is 1. That means plug 4 in to the derivative function and the answer will be 1. The third statement says between x equals 0 and x equals 4, the function is increasing. That means that the slope or the derivative function will be a positive output, a positive answer, for every number in between 0 and 4. Now let's take a look at part A. Part A says let f of x equal ax squared, where a is a non-zero constant. That means a could be just a positive number or a negative number, it could be a fraction, but it's not 0. Show that it's not possible to find a value for a, so that f meets requirement 2 above. So we want to prove that it's impossible to plug in 4 to this function and get 1 as our answer, but then plug 4 into the derivative function and get 1 as our answer using the same value of a. Let me show you what I mean. Here is the original function. And here I took the derivative. So I found the derivative using the power rule to be 2 times whatever number a is times x, and then you reduce the exponent by 1, so it becomes to the first power. I'm going to grab a highlighter, so this is going to be out of focus for a sec. Okay. So now I'm going to plug 4 in for x, because x equals 4. So I plug 4 into the original function, and I get 4 squared. So I get 16 times whatever number a is, and the answer has to be 1. Solving for a, I get a equals 1/16. We're trying to prove that that answer will not be the answer for the other part, the derivative function. So plug 4 in for x to the derivative function, and you're going to get 4 times 2, so 8. When you solve, you get a equals 1/8. We've proven that there is no number for a that will make both the function and the slope equal to 1. I'm going to move on to part B. Part B gives us a different format for the function. cx cubed minus x squared divided by 16. We need to find the value that will make all this work. The process is the same. Take the derivative, plug in 4 for x, solve for c, making both the original and the derivative equal to 1. So I'm going to let you look at my work here. Plugged in 4. I carefully solved the equation. This is all Algebra 1 and Algebra 2 material. And I got the exact same answer for both. I got that c equals 1/32. So I have found the value for c so that g of x meets requirement 2. I'm ready to move on to part 3. Part 3 says using the function g, so using the same function, and your answer for c from part B, show that g does not meet requirement 3 above. In other words, show that when we use 1/32 for c, the function will not be increasing at every point between 0 and 4. So what I did is I focused on the slope, because I know the slope will tell me if it's increasing or decreasing. My slope function, remember, was 3cx squared minus x/8. And I got that using the power rule from the original function. I plugged in my value for c into the value for c in the slope function, and I simplified to 3/32 x squared minus x/8. Now I need to prove that in between 0 and 4 there's at least one point where the function's decreasing. First I tried 0 and it gave me 0, but then I reread the problem and it says between 0 and 4. So that means that it has to be some number in between. It can't be 0 itself because it doesn't tell us that it's including 0. So I tried 1 next. When I plugged 1 in for x and I did the math, I got a negative slope. So I found on my first try that the slope was negative when x equals 1, and that's enough proof to say that the function's not always increasing. Now let's move on to the last part, part D. So you've read the instructions to part D. Let me show you the work. We need to show that this equals 1, and that when we take the derivative using the power rule, that it will also be equal to 1. The challenging part of this is the algebra. Plug in 4 for x into both the original and the derivative. Notice that we can't actually solve for one of the letters in this first one, but we can find, by multiplying both sides by k, that k is equal to 4 to the n power. And so over here, when I see k, I'm going to replace it with 4 to the n power. So now I have all one letter. I have only n. Now I know that it's possible, probably, to solve this. Notice that 4 to the n minus 1 has one less value for its exponent than 4 to the n. So if n was 8, then this would be 7. If n was 12, this would be 11. But this will cancel perfectly with every multiple down here except for 1. There will be 1 left over on the bottom. So this term, this is the most difficult part of this entire problem in my opinion. This term will cancel perfectly with this term, except that there will be 1 left over on the bottom. There will be 1 multiple of 4 left over. So I'm left with n divided by 4 equals 1. From there I can multiply to find that n equals 4. And then I can plug that answer back in right here to find that k equals 4 to the 4th power, or 256. My last step is to prove that these answers meet the requirements from part 1 and part 2. Requirement 1 says that when x is 0, the function equals 0, and the slope equals 0. I proved it right here. Requirement 3 says that the slope will be positive between 0 and 4. So I wrote the slope function, and I am proving, I'm positing, that the slope is positive when between 0 and 4. It's the full solution. See me if you have questions.